Hello and welcome to another exam paper walkthrough. Today we're looking at the past exam papers and we're looking at the summer 2017 series, and today I'm recording a video of the paper 1H. So it was sat in 2017, the first exam under the new spec, and this is paper 1H. Fantastic revision for any exam series that you may be facing. Okay, attached to the description of this video is a link that will take you to a PDF copy of this paper. It's just got my QR code which takes you directly to the video. So I would strongly recommend you either have a copy of the paper done beforehand, or you do it alongside the video, pausing and playing. Pause, try a question, play to see whether you got it right. That kind of process. I tend to have music on in the background. I tend to put some music on my ear pod while I'm recording this, just to save just listening to my voice. Just having something on in the background might help you get through this a little bit easier. Hope you find it useful. Subscribe if you like, and we will start. Okay, question 1. So we're looking at scatter graph shows the maximum temperature of number of hours of sunshine in 14 British towns on one day. Part A, write down the coordinates of the outlier. So the outlier is the one that doesn't fit the pattern. So we're looking at this one here, which is at coordinate 10, 19, so the coordinate will be 10, 19. For all other points, write down the type of correlation. Well, we've got positive gradient, so it means that it is a positive correlation. And then part C, on estimate the number of hours of sunshine on the town in this day. So we're given 16.4. It's always a 2-mark question. If you're precise, you can get the mark without this, but I would always strongly recommend you draw a line of best fit. So I'll put one in very roughly. So I'm going to start, let's say here, and we're going to go to here. Let me just make that blue. Okay, so am I happy with that? Let's just move that ever so slightly. So yeah, I think that's as good a line as I'm going to get. And then we're going to use that to make our estimate of 16.4 hours of maximum temperature. So 16.4, if we go across to our graph, we hit it sort of here. Here. So 16.4, we're looking at 12.8-ish. So that would be 12. Yeah, I'm going to go 12.8. And there'll be a bound of error on that one. So let me just bring up the mark scheme. Give me a minute. Okay, so the mark scheme says that it will allow anything between 12 and 13. Right, a weatherman says temperatures are higher on days where there is more sunshine. Temperatures are higher on days where there is more sunshine. Does the scatter graph support what the weatherman says? Initially, I would say yes, it does. The higher the temperature, the more hours of sunshine. But if we actually look at the wording, and you'd be absolutely fine with this, so don't worry about what I'm saying overly. It says temperatures are higher. It doesn't mention maximum temperature. So if somebody said temperatures, I would kind of assume that we mean the average temperature, and we haven't got the average temperature, we've only got the maximum temperature. So I'm actually going to go kind of against the grain. I'm going to say no. It only shows maximum temperature. Or no, it shows maximum temperature. Temperatures are higher on days with more sunshine. But you could get away with yes would be the obvious answer. I'm just going a bit more technical on it. If you've gone yes and said the graph shows that the higher the temperature, the longer the hours of sunshine. I'm sure you'll be absolutely fine. They're just after some good understanding of the graph. Okay, question 2. Express 56 as a product of its prime factors. So I tend to, on a non-calculator, we would be using a factor tree. I always take off my highest factor, my lowest factor. So that would be 2 times by 28, which is 2 times 14, which is 2 times by 7. So we could do 2 times 2 times 2 times 7, or 2 to the power 3 times by 7, writing it in index form. Question 3, work out 54.6 times by 4.3. So I will ignore the decimals for now. I'll discuss them in a little while. And I will just do the multiplication of 446 times by 43. So 6 times by 3 would give me 18. 3 times by 4 would give me 12, plus the other one would give me 13. 3 times 5 would give me 15, plus the 1 would give me 16. Now I put 0 in my units column, and then I'm timesing by 4. So 4 times by 6 is 24. 4 times by 4 is 16, plus the 2 is 18. And then 4 times by 5 is 20, plus the 1 is 21. Add those two numbers together gives me 8, 7, 3, 2. So my digits for this will be 2, 3, 4, 7, 8. So the decimals don't affect the digits. They affect where the decimal place goes. So I've got 2 decimal digits in my question, so I'll have 2 in my answer. So I'm going 234.78. So 247.40. Try again. My teeth in properly. 234.78. Okay. For this question, the area is 10 centimeters squared. Show that. So I'm going to do my multiplication. I would normally treat this as brackets, but I'm just going to do it on a grid because we've got a grid here. 3 times by 3 would give me 9. The area of each of these is going to be what I'm working at now. 3 times by x would give me 3x. 3x times by 3 would give me 3x. And then x times by x would give me x squared. So that's the way we can multiply it out anyway. If we then tidy that up, so x squared plus 6x plus 9 is equal to the area, which we're told is 10. Then if I minus 9 from both sides, I get x squared plus 6x is equal to 1, which is what we're asked to show. Okay, so for this one, a rectangular frame made from 5 pieces of metal. The weight is 1.5 kilograms per meter. So we need to work out the distance of these 5 rods. Currently, though, we don't know this value, but that value is going to be equal to, well, that value squared is going to be equal to, using Pythagoras, 12 squared plus 5 squared, which would be 12 squared is 144, 5 squared is 25. So that's going to be 169, which is square root. It would be 13. So the perimeter of that, not the perimeter, well, total amount for the metal is going to be 2 lots of that plus that. So this plus this, because we've got another value there and another value there, plus 13, which is going to be equal to 2 times by 17 plus 13. Which is going to be 3047. We then need to work out the weight of that. So we need to times that by 40, times that by 1.5. So 47, a bit like before, 47 times by 1.5. So I'm going to times by 15. So 5 times 7 is 35. 5 times 4 is 20, so 23. 0 in my units column, 47 there. Add them together, 5. So we've got 70.5. So total weight is going to be 70.5 kilograms. Okay, equation of L1 is y is equal to 3x minus 2. Equation of L2 is 3x minus 9y plus x is equal to 0. Show that these two lines are parallel. So line 1 has a gradient of 3 because it's already in that format. Y is equal to mx plus c, and an actually we'll say nc of minus 2. The second line, it starts out as 3y minus 9x plus 5 is equal to 0. So if we rearrange that, we're going to say that 3y is going to be equal to 9x minus 5, and then divide both sides by 3, we get y is equal to 3x minus 5 over 2. So that line has a gradient of 3 and an intercept of minus 5 over 2. So both lines have the same gradient and different y-intercept. So are parallel. Okay, question 7. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for the class is 60. The mean marks for the girls is 54. Work out the mean mark for the boys. Okay, so in effect, what we need to do is the total for the class, which would be 60 times by 30. From that, we need to take away the total of the girls' marks, which is going to be 45 times by 20. And then we need to divide our final answer by the number of boys, so by 10. Okay, so in effect, we can make this a little bit easier for ourselves and cancel down by a factor of 10 in all three parts, the denominator, and we've got it as a factor of the numerator. So 6 times by 3 is 180, and then 5 times by 2 is going to be 108. So the mean mark for the boys is going to be 180 minus 108, which is going to give us 72. Okay, question 8 then. Write as an ordinary number. So when I'm writing a standard form number with a negative, I view it as that's how many zeros we need to add before this number. So I go 1, 2, 3, 4, 5, 6, 7, 9, 7. And then just double check. 1, 2, 3, 4, 5, 6. Yep, that's fine. Work out the value of divided by 4. Okay, give your answer in standard form. So I tend to split this into the number part, which is 2.52 divided by 4, and then the index part, 10 to the 5 divided by 10 to the minus 3. So my number part, then, if I halve it, I'd get 1.26. So let's just go 252. Half of that would be 126. Half of that would be 64, 63. So I'm looking at 0.63 as my number part, times by 10 to the, and then when we subtract these when we divide, we subtract the power. So 5 minus 3 becomes to the 8. Then we would need to convert that to be in standard form. So 6.3 times 10 to the, and we need to go one less, so to the power 7. So 6.3 times 10 to the power 7. Okay, Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules has to pay a total of £600. What is the price of the washing machine with no VAT? So technically speaking, then this £600 is 100% plus the 20% VAT, so it's 120%. So I then need to build that back up to 100%. So realistically, if I divide it by 6, I would get 20%. So 20% is £100, and then times that by 5. So 100% would be £500. So the original price was £500. Question 10, show that, so we've got a triple bracket to expand. So I always pick the more difficult of the two brackets to expand first of all. So I'm going to expand this part first of all. Oops. So if I expand that, I would get x squared, 3x plus 2x would be 5x, plus 6. And then I need to do this second part, well, third part, x plus 1. So I'm timesing it by x plus 1. So I tend to set this up as a column kind of multiplication. So I times everything by x first of all. So that would give me x cubed plus 5x squared plus 6x. And then I times by 1 and I line them up. So 1 times by x squared would give me x squared, 5x and plus 6. I've missed a plus sign there. And then I add those two together. So that would give me x cubed plus 6x plus 11, 11x plus 6. So I haven't got an answer line space, so I'll just double underline it. Okay, graph of y is equal to f of x is drawn in the grid. Write down the coordinates of the turning point. The turning point is going to be there. So the coordinate of the turning point is going to be 1 minus 3. Write down an estimate for the roots where it is equal to 0. So we're trying to find where that line and that line cross. So if I'm estimating that, that's looking about minus 0.75. And the other one is looking like minus 2.75. For the graph, find an estimate for f of x is equal to minus 1.5. So in effect, that's where x is 1.5. So I'm looking at this line here. So I need to work out the value of y there, and it's looking like minus 2.8. And that's it for that question. Okay, question 12. Find the value of 81 to the power of minus a half. Well, the minus means take the reciprocal, so that's 1 over 81 to the half. And then half means square root, so the square root of 1 is 1. The square root of 81 is 9, so it's just 1 over 9. Similar-ish process here, so I'm going to do the third first of all. So the third is the cube root of 64. The cube root of 64 is 4. And then the cube root of 125 is 5. And then squaring that would give us 16 over 25. Okay, question 13. This table shows a set of values for x and for y. Y is inversely proportional to the square of x, so that means y is equal to k over x squared. Find an equation for y in terms of x. I'm not quite there yet. I need to plug in a set of values. I'm going to plug in the first ones. So 9 is going to be equal to k over 1. So k is going to be equal to 9. So my actual equation would be y is equal to 9 over x squared. And I picked the most simple one, but we could have done it with the other ones. So if we use these, I would get 1 is equal to k over 9. So I'd still get 9. Find the positive value for x when y is equal to 16. So that's saying that 16 is going to be equal to 9 over x squared. So if I rearrange that, that means that x squared is going to be equal to 9 over 16. And then square root that. It says the positive version only. So x would be equal to, square root of 9 is 3 over 4. Okay, question 14. White shapes and black shapes are used in a game. Some of the shapes are circles, some of the shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The number of white circles to the number of white squares is 4 to 5. The ratio of the number of black circles to the number of black squares is 2 to 5. Work out a fraction of the shapes that are circles. Okay, so I'm going to kind of split this into a bit of a ratio table. So we've got black. I'll do it the other way around actually, because that's how it's written. White to black. So I'm going to put white to black is 3 to 7. Then we've got white circles to squares. So if I kind of split this circles to squares, squares to circles to squares, for the white it is 4 to 5. And then for the black circles to the number of black squares is 2 to 5. So again, circles and squares is 2 to 5. Work out the fraction of all shapes that are circles. Okay, so if we think about this, then 3/10 of them, we really want, this is kind of the key information. So we've got 3/10. So if I just look at circles, we've got 3/10 of the circles are white, and then 4/9 of those are circles. So that's the proportion of white circles. If we look at black circles in a similar fashion, we've got 7/10, and then 2. I'm not sure why I put 12 there. That should have been 7. And 2/7 of them are circles. Okay, so we've got. Let's simplify as much as we can. I'm just trying to work out whether simplifying. Right, so we can actually cancel that and that. 2 goes into 5 and 2, and then 1 and 3. So we've actually got 2/15 are white circles, and then likewise over here. And 1/5 of them are black circles. So if we add those two together, so 2/15 plus 1/5 becomes 2/15 plus 3/15. So that would be 5/15. And 5/15 is the same as 1/3. So 1/3 of them would be circles. Okay, question 15. A cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13. Work out an estimate for the height of the cone. Okay, so let's use this formula and plug in kind of what we know. So we've got 98. The volume is equal to 1/3 of pi times by the radius squared times by the height of the circle. So I'm now going to use some approximation. I'm going to say that 100, so I'm going to say, we'll do it here, 98 is approximately equal to 100. I'm going to say pi is approximately equal to, I'm only going to one significant figure, 3, and I'm going to say that the radius is approximately equal to 5. So 100 is going to be equal to 1/3 times by 3 times by 5 squared times by the height. So that would cancel. So we've got 100 is equal to 25 times by the height. So the height is approximately equal to 4. Try and use the calculator to work out the height of the cone to 2 decimal places. Will your answer be more than John's answer or less than John's answer? Well, we rounded down here, and we rounded up here, and we rounded down here. Okay, so I'm gonna so my answer here is bigger than the actual answer. My answer here is smaller My answer here is smaller. So overall, my answer is a bigger number divided by a smaller number. So my answer is going to be an overestimate. Will your estimate be more than John's? Yes. Yes. As my final denominator is bigger and my final, sorry, I've done that the wrong way around. My final numerator is bigger and my final denominator is smaller than actual answer. And I've messed up slightly there. It's not a yes or no question. Will your answer to John's answer be more or less? More. More, as my final numerator is bigger and my final denominator is smaller than the actual answer. There we go, that's fine. Okay, question 16. N is an integer greater than 1. Prove algebraically that n squared minus 2 minus n squared minus 2 all squared is always an even number. So we'll come back to the greater than 1. Well, it doesn't really matter. It just means that we're looking at positive numbers. So what I'm going to do is I'm going to start with this part and square that out. So I'm going to put minus, because well, I'll do the whole thing. N squared minus 2 minus n squared minus 4n plus 4. That squared that. Then if I simplify that, n squared minus n squared would cancel. I've got minus 4n, so that would be 4n. Then my number part becomes minus 2 minus 4, so that would be minus 6. So I can take 2 out as a common factor. 2n minus 3. So it must be even. So it must be even. As will be a multiple of 2. There we go. Okay, question 17. There are 9 counters in a bag. 7 of the counters are green, 2 of the counters are blue. Ria takes at random 2 counters from the bag. Work out the probability that Ria takes 1 counter of each colour. You must show your working. So in effect, we'll go straight into this. Sometimes with these questions, it's easy to work out the kind of the not happening and then take it away from 1, but it makes very little difference here. So probability of picking a green and then a blue is going to and then I want to add that to the probability of picking a blue, then a green. So probability of picking a green counter, first of all, is going to be 7 out of 9. Takes 2 counters, so we've probability of picking a blue counter then is going to be 2 out of, but we've only got 8 counters, so 2 out of 8. To that, I want to add the probability of picking a blue counter first of all, which would be probability of picking a blue counter first of all would be 2 out of 8, and then followed by a green counter, which would be 7 out of 8. Okay, so I'm just looking whether it, and I've made a mistake there. I'm just looking whether it's going to be easier to simplify down. Problem with simplifying down is I will often lose my denominator, but in this question it doesn't make any difference. I can cancel down here and here. Let's do this in a different colour. So I can cancel down by a factor of 2 here, so that would be 1 and 4, and I can do the same here, 1 and 4. Okay, so 7 times 1 is 7, over 9 times by 4 is going to be 36. plus probability 7 out of 36 again. So it's going to be 14 out of 36. We can cancel that down because we've got two lots of it in effect. So we can cancel that by a factor of 2. So 7 out of 18 would be my final answer in its simplest form. And I'm assuming that you would be fine not simplifying because it doesn't say in its simplest form. So you could have had, let's think about it, that would create 14, 14, 72. So you could have had 28 out of 72, 14 out of 36, or 7 out of 18. Okay, question 18. So we've got ABCD is a rhombus. The coordinates of A are 5, 11. So I'm just going to add that in here. 5, 11. You're told the equation of the diagonal, so we're told the equation of this line is y is equal to a half x plus 6. Find the equation of the diagonal. So the diagonal, so I'm going to call it y. So this is going to be y is equal to mx plus c because it's going to be a straight line. Okay, find the equation of the diagonal AC. Okay, so we've got the coordinate that it passes through, and we've got the perpendicular gradient. These would cross at 90 degrees. So if the gradient of d, so let me write this a little bit better. So the gradient of dB is equal to a half. So the gradient of AC is going to be the negative reciprocal, so it would be minus 2. So we've got so far y is equal to minus 2x plus c, but we know that it passes through the point 5, 11. So 11 is going to be equal to minus 2 times 5 is minus 10 plus c. So add 10 on both sides, 21 is equal to c. So we've now got the equation of the line. The equation would be y is equal to minus 2x plus 21. Okay, question 19. So OABC is a parallelogram. O to A is A, O to C is C. X is the midpoint of the line AC. So X is the midpoint of AC. OCD is a straight line such that OC to CD is K to 1. So we've got another point. If we extend this line, we've got another point here, D, and the ratio is K to 1. Given that X to D is 3x minus a half A, find the value of K. Okay, so X to D is 3C minus a half A. Okay, so the way I'm going to do this is I'm going to say that A to C is going to be equal to minus A plus C. So X to C is going to be equal to a half of that. And then in effect, C to X C to X is going to be equal to minus X to C plus X to D. So that's going to be equal to minus a half of minus A plus C plus 3c minus a half a. Okay, so if we look at that, that is actually going to give us a half a plus, no, sorry, minus a half c plus 3c minus a half a. Right, they would cancel, so we end up with 5 over 2c. And we can kind of go from there. So k to 1 is 1c. Sorry, let me just do this again. So we've got O to C and C to D. So we've got, that's the form we want it in. The form that we've got it in currently is 1 to 5 over 2 though. So if we rearrange that, that would be 2 over 5 to 1. So K would be 2 over 5. Okay, question 20. Solve algebraically the simultaneous equation x squared minus plus y squared is equal to 25. So I'm going to rearrange equation 2. So equation 2 is equal to y is equal to 3x plus 13. So I'm going to sub my value for y into equation 1. So that would give me x squared plus 3x plus 13 squared is equal to 25. So that would be x squared, and then if I square this bracket out, that would give me 9x squared plus 39x plus 39x plus 169 is equal to 25. Right, let's try and tidy that up then. So that would give me 10x plus, this would give me 78x squared, and then 169 minus 25 is going to be 144 is equal to 0. Then I'm going to tidy this up a little bit further, although I'm tempted because that is a square number. But let's just divide everything by 2. That would give me 5x squared plus 39x squared. That squared shouldn't be there. Plus 72 is equal to 0. I'm going to see whether that factorizes. For that to factorize, we must have a 5x here and an x here. And then two numbers, if we look at 72, two numbers that multiply together to make 72 would be 24 and 3. And then to make 39, 39 is made from 24 plus 15, so that would work. So the 3's go in there and the 24's go in there. So that gives me two values for x. I'm going to do it just down here a little bit. So to make this first bracket 0, x would need to be equal to minus 24 over 5. And to make the second bracket 0, x would need to be equal to minus 3. So I'm now going to sub my value for x into my initial equation. I'm going to do the easy one first, just because I'm a bit lazy. So y would be equal to minus 3 times by, set that out slightly wrong, 3x, so 3 times by minus 3 plus 13. So that's going to give me minus 9 plus 13 would give me 4. So that's my first pair. My second pair then, so if I times this by 3, y would be equal to minus, 3 times by minus 24 over 5 plus 13. Right, so that's going to give me, timesing that by 3 would give me minus 72 over 5 plus, and I'm going to convert that into a fraction over 5 just because I know I'm adding, so that's going to be 65. I'm just trying that in my head. 3 times 5 is 15. Yeah. Okay, and then when I add those together, then I'm going to get minus 72 plus 65 is going to give me 7. So that's my second value. Ooh. Okay, and if I'm not going to do it now because it would take a little bit of time. If I finish this exam in plenty of time, I can actually go through and check by substituting these values in. I'll quickly do it for the first easier one. So 3 squared, well, minus 3 squared is 9, plus 16 would equal 25, so that definitely works for the first pair. I'm not going to do the second pair because I'm going to struggle to do that in my head quickly, but we could put a note that we need to check that at the end. So I'm going for my pairs of values are x is equal to minus 24 over 5 and y is equal to minus 7 over 5, or x is equal to minus 3 and y is equal to 4. Okay, question 21, we've got a quadrilateral. AB is equal to CD. Angles ABC and angles BCD are equal. Prove that AC is equal to BD. So AC is equal to BD. Okay. Right. So I'm going to say that ABC is equal to BCD. As stated. I've probably done this slightly out of order, but that's fine. And then I'm going to say that AB is equal to CD, as stated. And then BC is a common side. BC is equals BC, and then common side. And then what I've actually said then is so triangles ABC and BCD are congruent as two sides and the included angle are equal. So I've lost some of my writing. Let's move that back down. So sides AC must be equal to BD. And that's going to be my argument, so my proof. Okay, question 22, diagram shows a hexagon, and we're given that they're congruent parallelograms. AB and BC are both equal to x, so we'll call that x and x. And we're told that P is the midpoint of the parallelogram such on the CD such that P to B and B to Q is 10 centimeters. Given that the angle A, B, C, A to B to C. So let's change the pattern colour for that. Given that that angle there is 30 degrees, prove that cos of B, PBQ, so we're trying to work this out, is equal to 1 minus, and we're given that. Okay, we can't work out this angle yet because we don't know this length here. So I'm going to call this length here y, but I'm also going to say that that's equal to AC. So I'm going to work that length out first of all. So using the cosine rule, y squared is going to be equal to x squared plus x squared minus 2 times x cos of 30. So cos of 30 is equal to root 3 over 2. So let's tidy this up a little bit. So y squared is going to be equal to 2x squared minus 2x squared times by root 3 over 2. So y squared is going to be equal to 2x squared minus root 3x squared. So we could take x squared out as a common factor here. So 2 minus root 3 x squared. Right, I'm going to leave it at that point for now. Now I'm going to look at the actual angle that I'm trying to work out. So I should have given myself a bit more space here, but that's okay. Now I'm dealing with AC, so y squared is going to be equal to 10 squared plus 10 squared minus 2 times 10 times 10 times by cos of the PBQ. Okay, so tidying that up, then we get 10 squared plus 10 squared is going to be 2 lots of 10 squared, so that's going to be 200 minus 2 times 10 minus 200 times by cos of the angle. Cos of the so I've written cos twice, PBQ. So I'm going to put these two parts equal then, so y squared is equal to that. So I'm going to, where should I carry this on? So let's do it over here. So we're in effect saying then that 2 minus root 3 of x squared is equal to 200 minus 200 cos of the angle that we're after, PBQ. Right, so if we rearrange this then, so in effect we're going to have, if I take this over to this side, 200 cos of the angle that we're after, PBQ, is going to be equal to 200 minus 2 minus root 3 x squared. And then if I divide through by 200, I get cos of PBQ is equal to 200 divided by 200 is 1. So I'm just left with minus 2 minus root 3 over 200 x squared, which I think was what we were asked to show. 1 minus 2, yeah, that's what we were asked to show. Okay, so that brings us to the end of the paper. I'm just going to bring up the skills map. Okay, so that was 22 questions. There is the topic that each question was on. So, for example, if you struggle particularly on question 14, that was relate ratios to fractions and to linear functions. So that might be where you focus some of your independent revision. I'll also be chaptering by those topics, so I've got that ready to upload. So I hope you found that useful. Please feel free to add any questions, comments or feedback into the chat for this, and I'll get back to you fairly quickly. Thanks for your time in watching. If you've enjoyed the video or find the video useful, should we say, subscribe if you like. Thank you, and I will see you soon.